Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, and dedicated CPU and GPU instances. And now you can launch a managed MySQL, Postgres, or Mongo database cluster in minutes to keep your critical data safe with automated backups and failover. Go to pythonpodcast.com/Linode today to get a $100 credit to try out their new database service, and don't forget to thank them for their continued support of this show. So now your modern data stack is set up. How is everyone going to find the data they need and understand it? Select Star is a data discovery platform that automatically analyzes and documents your data. For every table in Select Star, you can find out where the data originated, which dashboards are built on top of it, who's using it in the company, and how they're using it, all the way down to the SQL queries. Best of all, it's simple to set up, and easy for both engineering and operations teams to use. With Select Star's data catalog, a single source of truth for your data is built in minutes, even across thousands of datasets. Try it out for free and double the length of your free trial today at pythonpodcast.com/selectstar. You'll also get a swag package when you continue on a paid plan. Your host, as usual, is Tobias Macey, and today I'm interviewing Fridolín Pokorný about Project Thoth, a resolver service that computes the optimal combination of versions for your dependencies. So, Fridolín, can you start by introducing yourself?
Thanks for having me. I work as a software engineer in Red Hat's Office of the CTO, the group that is called Emerging Technologies Group. And more specifically, I work on a project that is called Thoth, and it's a project made out of multiple parts. I think the most interesting one for this talk is Thoth's resolver that can resolve application dependencies similarly to pip, but in a more clever fashion, let's say.
And do you remember how you first got introduced to Python?
It was back in 2012, I think, during my university studies. And I was impressed by Python because it's really a pseudocode. You just write on whiteboard while you're discussing problem, and then you write it in your to a file, and it suddenly works. It's like magic.
And so in terms of the Project Thoth that we're discussing today, I'm wondering if you can give a bit more context around what it is that you've built there and some of the story behind how it came to be and what the overall goals are.
Project Thoth started in 2018 as a research project in AI division at Red Hat. We wanted to create a system that would help developers to create healthy applications, developing Python applications. There were two main use cases. One was developing Python applications locally. When people use pip, sometimes not that clear which versions of libraries should be used and if they are compatible between each other. But there was also another use case, like running Python in containers in a cluster, where you have containerized environments and would like to utilize software environment that is provided by the containerized environment and make sure that software layer of an application works well with hardware and you get the best possible performance, also security of the application that you are developing and things like that.
As far as the types of problems that you have seen, and you mentioned pip doesn't always give a very good or clear answer as to what are the actual versions of the transitory dependencies that I have. What are some of the types of problems that can be introduced by having versions that aren't sort of optimally determined or that aren't locked to a specific version or a specific release for those non-primary dependencies?
So we spotted multiple issues when it comes to library incompatibilities. So for example, we had issue when installing Pillow together with NumPy, and there was not respected properly API calls, and that made the application crashing. Or there were issues with Python versions, with Python interpreter versions. Some libraries were not ready for more recent Python interpreters, and that caused issues. Besides this Python layer, you can find other issues when using, for example, TensorFlow. If you use TensorFlow together with a GPU, you need to make sure that it fits correctly, so you have a proper CUDA version installed, things like that. And the only way how to make this work is to basically browse documentation of library and make sure you have proper CUDA version installed, for example, the right glibc valuable, and this causes headaches to developers because it's something that could be answered, let's say, automatically during the resolution process. And the resolver can say this combination of libraries in your environment will not work properly.
As far as the overall ecosystem in Python for being able to manage the dependencies, pip has been maybe the longest running one that's still in use. And there are a number that have grown up as well. Some of the notable ones being Poetry and pipenv and pip tools. And I'm wondering if you can just talk to some of the ways that what you're doing with Thoth is either an improvement on those tools or works alongside them, and just some of the, specifically in terms of the dependency resolution, some of the ways that Thoth approaches it in a different manner than what those tools provide.
If you take a look at pipenv, Poetry, these resolvers all run locally. So developers install applications locally, and the actual resolution process is done on client machines. The design of Thoth is different. Thoth's tooling aggregates information about client's environment, where clients run their applications, and send this information to Thoth's backend. And the backend, based on pre-aggregated knowledge about dependencies, can resolve application dependencies specifically for users, for these clients. You can see it as a guidance service in this case, because it does not solely resolve these applications just by looking at dependency graph, but it also considers additional knowledge about these dependencies. It can be, for example, quality of these dependencies, like security aspects. Does the given dependency have some vulnerability? Or do these dependencies work well together? Or what about communities? Are these packages backed by a good community, by a healthy community, so that I can trust these open source packages? If I'm using, for example, recurrent neural networks, the resolution process can be different for my use case. And using these, the resolver can behave differently. So it's synthesizing software and hardware as aggregated by client's tooling, and also doing some kind of contextual resolution when, based on static source code analysis, the resolver can guide which packages and package versions a user should use.
As far as the implementation of Thoth itself, I'm wondering if you can talk to some of the various components in the overall ecosystem of what Project Thoth encapsulates, and then in terms of the actual resolver itself, some of the ways that that is architected and implemented to be able to provide this resolution as a service.
Clients tools include Tamos CLI, that is a command line interface for contacting Thoth. It does the mentioned aggregation about the environment and sending information to the backend, as well as consuming results that are computed by backend. We have also Jupyter Lab requirements. This is an extension to Jupyter notebooks that can contact Thoth as well. And besides that, it embeds packages or information about packages to Jupyter notebooks. So if you share a Jupyter notebook, then you have a reproducible or information to have packages reproducible, and you know what packages were used during the resolution, during the application development. We also provide bots that can be used by community. These bots perform releases of Python modules, but also let update repositories with Thoth recommendations. And these are client tools that can be used. All of them contact backend, and the actual resolution is implemented in a component that is called Advisor. It's a stochastic resolver. It implements temporal difference learning, and in that case, the whole dependency graph is explored, what are the possibilities, how to resolve application dependencies, and the resolver learns how to resolve the best possible combination of dependencies. Then there are other components that make sure that data that are stored on backend are fresh and available to be used during the actual resolution process.
As far as the goals of the project, you mentioned that it started off as a research exercise and has now grown into a full-blown engineering project. I'm wondering if you could just talk to some of the ways that it went through that evolution and how the initial ideas of what was trying to be achieved with that research project has evolved into the current scope of what you're trying to build with Thoth.
We had pretty quick development, and I personally liked it because it was like, let's create a prototype, let's prove it works, and if it works, let's try to incorporate it into the system. I think we took many blind paths when it comes to implementation. It was sometimes completely rewritten. I think we switched database twice. Originally, we used graph database, but the problem that we were trying to solve proved it doesn't require a graph database, and we use relational database that proved to be scalable for this problem and proved to work.
As far as the pieces of information that the resolver is using for determining what the overall possible solution space looks like and then figuring out the optimal result, I'm wondering what are the core pieces of information that it's relying on? You mentioned sending along some information about the environment where the application is running, as well as the set of dependencies that you're trying to work with. So I'm just curious if you can talk to sort of how that possible solution space is constructed and how the Thoth resolver is able to explore that space and find the optimal result.
Thoth resolver combines multiple sources. For example, we use advisory database that is maintained by the packaging authority, and it stores information about vulnerabilities in Python packages. We use also scans of container images as produced by Quai, and these include information about vulnerabilities in container images on RPM level, for example. Then the background aggregation logic also gets information from GitHub. So, for example, it takes a look at contributors, how many contributors a project has, or if it is forked, or if it is archived. So users and consumers of these projects are warned that the project is archived. We also compute popularity. So based on stars, number of forks, we say that a given project is popular or not that popular, and the user is possibly consuming some not that known package in the ecosystem. We also take a look at how these projects are updated. So if they have healthy community, if the project has recent commits and things like that. We also take a look at PyPI, which was these packages. We take a look at downloads and maintainers. So if a project has low number of maintainers, that might look like it can produce, or if a project has not that lot of maintainers, it might warn users that project might be not that maintained and lose contributions over time. We also take a look at open source security foundation. They compute something that is called security scorecards. They check if a community, for example, signed releases of packages, or if they use CI checks. So pull requests are properly reviewed and changes go properly to the code base.
As far as the actual process of starting to work with Thoth and saying, I have an existing project, I have my dependencies tracked in whether it's a requirements.txt file or a pyproject.toml, and now I want to take advantage of Thoth's resolver to make sure that I am not subjecting myself to security issues or that I'm not inadvertently introducing some dependency conflicts. And so I want to actually, send my requirements to Thoth and make sure that I can improve the overall dependency list from that and, generate a lock file that I can actually use for production.
The best way to start is to use Tamos CLI in this case. You can install it using pip install Tamos, and in that case, you will have Tamos command available in your environment. It will show you some help message if you run Thamos --help. The most interesting or the most important commands could be Thamos add, which adds dependencies to your project. Thamos itself consumes formats that are similar to pipenv. So if you use pipenv and you use pipfile and pipfile.log, then the workflow naturally integrates. But Thamos can also consume requirements files. So once you add requirements to your project, then you can call Thamos config that generates a configuration file and automatically detects what is present in your environment. In this configuration file, you can find information about software that is present in the environment. So for example, if you use CUDA, tooling will store CUDA information in the configuration file, but also information about operating system, Python version that you are using. After this initial setup, you can call Thamos advice, which will contact backend with provided information and will wait for the backend to respond. Once backend computes recommendations and provides a log file for you with all the dependencies pinned to a specific version, then Thamos obtains this information from backend and can install your dependencies using Thamos install. The overall workflow is similar to pipenv, but we have that special Thamos advice command is somehow different from pipenv log.
I know that on the landing page for Thoth, it also makes a mention of being a recommendation engine for your Python projects. And I'm wondering if you can talk to some of the types of recommendations that it can make and what kinds of information you need to feed to it to be able to generate some of those recommendations and how that might differ from just using a list of dependencies that I want to get a lock for.
The resolver itself works on requirements files and also constraints that you provide to the resolution process, also with information about environments that is stored in the configuration file. So it's very similar to what pipenv do. When you would like to explore what are the possibilities, you are developing web application, you would like to get information what libraries are out there and what libraries you can use. We have developed a model that is called Project Thoth that basically creates vectorized representation of Python projects that are available on PyPI. And in that case, you can see clusters of packages. So let's say one cluster keeps packages that are related to web application. Another cluster can store information which packages are related to machine learning. And a nice thing about this model is that you can query it because these projects are represented using vectorized representation. And in that case, you can create your vector. And in that vector, you can encode that you are interested in web application that runs on Python 3.8 and Python 3.9. And the vector then forms a mask that can be used to query large project to web representation. This model is under development and it's not available on Thoth endpoints yet.
Need to automate your Python code in the cloud? Want to avoid the hassle of setting up and maintaining infrastructure? Shipyard is the premier orchestration platform built to help you quickly launch, monitor, and share Python workflows in a matter of minutes with zero changes to your code. Shipyard provides powerful features like webhooks, error handling, monitoring, automatic containerization, syncing with GitHub, and more. Plus, it comes with over 70 open-source, low-code templates to help you quickly build solutions with the tools you already use. Go to pythonpodcast.com/shipyard today to get started automating with a free developer plan. As far as the extensibility and integrations available for building with or on top of Thoth, what are some of the ways that you have designed for it to be extendable and so that people can, customize its behavior or be able to contribute some additional functionality to it?
The whole project is open source, so you can find the sources on GitHub in ThothStation organization. We also provide README file, how you can set up your own Thoth locally with some limited or some restrictions. And if you would like to contribute directly to what the recommendation engine can provide to users. There's a pluggable interface that is called prescriptions. Prescriptions are basically YAML files that are stored in a Git repository, and this Git repository acts as an open database that is consumed by the resolver. These prescriptions state information about packages and projects. So if you would like to provide some information about projects to users of Thoth, you can state it in a prescription in a YAML file. And you can also state these library incompatibilities in prescriptions. So prescriptions really act as a database that can be consumed by the resolver to provide high quality resolution. Prescriptions provide a way how to state that some libraries have overpinning issues or underpinning issues, or do not perform well in certain environments, or some background data aggregation creates prescriptions automatically and store them in the prescriptions repository.
In terms of the actual functionality of Thoth, there's nothing that seems to be inherently coupled to the Python ecosystem, and I'm curious what you see as the opportunity and the work necessary to be able to extend it into other language communities for being able to resolve, say, Node dependencies or Java dependencies, and being able to, bring some of this functionality to other language environments.
That's an excellent question. I think some parts of infrastructure are not tightly coupled to Python, so they can be reused, like queuing system that is implemented or API service that accepts inputs from users. So the infrastructure could be extended. Then there are some aspects of this language ecosystem, such as Node.js or Golang or Java, that would deserve some kind of spike and check if all these ideas are suitable also for these language ecosystems. But I think at least some design patterns can apply also to other language ecosystems.
As far as the applications of Thoth, I'm wondering what are some of the most interesting or innovative or unexpected ways that you've seen it used?
Some teams use editable installations, and these editable installations do not fit well to that cloud-based resolution process because they require certain specific environment setup on client machines, and Thoth works solely on packages that are released on Python package indices. So that's one of the things that we found challenging. In the team, we have discussions if we want to support editable installations and if they should be supported or if they should be not supported.
And in your own experience of working on Thoth and helping to evolve the project and working with end users of it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think one advice that I can give is to set up quality checks as soon as possible, because technical debt is carried in the source code. So it's really good to set up some MyPy checks or pre-commit checks to make the repository healthy. We also found out that graph database is not always the right choice for graph-related problems and their own specific use case, but that was not suitable for Thoth. We also found that having good cluster setup and stable cluster is very valuable, because especially in the beginning we were having issues with fresh clusters, but that improved a lot over time, and now the OpenShift cluster that we are using is very stable, and some components would not be developed properly without this ability. Also, naming is hard. We found different issues with Thoth and pronunciation, especially if you are in a team that is distributed worldwide. And yeah, Python is a cool language and has very nice community. And it has one nice aspect, and that is if you find one or if you spot not that performing part of your application, you can still optimize it. And that's also a case for Thoth, where the whole application is developed in Python, but some very core parts of the resolver are implemented in C, C++, and that help to gain performance.
As far as the naming aspect, one of the things I forgot to ask earlier is where the actual name of the project originated, sort of what inspired you to name it after the Egyptian god of knowledge.
It was basically given by one of the directors who came with Thoth's idea, and we really liked it. And Thoth was not taken on by PI, so we were very happy about that namespace and having Thoth as name. But we have also other services that are called after Egyptian gods. And as I said, naming is sometimes hard, and this made smiles in the team, and it worked at the end of the day.
And so for people who are interested in being able to improve the, quality of their dependency resolution, what are the cases where Thoth is the wrong choice and they're better suited just sticking with, pip or poetry or pipenv or something like that?
So it can resolve application dependencies, open source projects. So if you consume open source packages, Thoth can be nice to use. But if you use packages that are hosted privately, internally on a private package index, then Thoth doesn't know how these packages are hosted, cannot access them, cannot explore what are the dependencies of these projects, and cannot guide on these projects. So Thoth is a service that is suitable for packages that are hosted on PyPI or publicly hosted indices.
As you continue to build and iterate on the Thoth project and its ecosystem, what are some of the things you have planned for the near to medium term?
We wanted to improve our UI, as Thoth provides also user interface if you want to browse and search results of advices. We also plan to integrate another component that is called license solver. It basically checks what licenses a package has and spots any discrepancies between declared licenses. So users can be warned about issues in licensing. We also plan to adopt Zigstore once it gets more mature in the Python ecosystem. And also, we would like to improve our community adoption. So if you have any feedback, feel free to try and send feedback to the developers.
On the note of contribution, are there any particular areas of input that you're looking for or particular skills or backgrounds that would be helpful?
I think extending Thoth's database, these prescriptions, that would be very helpful because the more prescriptions, the more information about open source packages Thoth has, the better recommendations it can give. So if anyone spots an issue with a package or finds out that some packages deserve information or warning to users, it's very valuable to have this knowledge accumulated in one central place so the whole Python community can benefit from this knowledge.
Are there any other aspects of the Thoth project or the overall space of dependency resolution and dependency management that we didn't discuss yet that you'd like to cover before we close out the show?
I think the dependency resolution is not that trivial task, and having information what the dependencies should be included in application, what are their quality and how to consume them, how to set up environments, that's something valuable. And if we have that knowledge accumulated, that would be great. So we extend the resolution process, not just providing or checking what version ranges are acceptable for application requirements that I have, but also including information about the actual packages, so some type of metadata about packages that are consumed and installed to clients' machines.
Awesome. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing and contribute to the Thoth project, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose a musical group that I came across recently called Brass Against. They seem to mostly do cover songs, but they're a heavy metal group that has a horn section, so hence the name. So it's interesting hearing them do covers of things like Tool songs, System of a Down songs with a horn section as a backing ensemble. So definitely worth checking out. Rather different style than I've heard most other places. So with that, I'll pass it to you, Fridolín. Do you have any picks this week?
You can check another project that was created in Thoth, and it's called MicroPipenv, a tool that extends pip, and it can install dependencies that are stated in depend, poetry, or requirements.txt files. And in that case, it can install dependencies very quickly. So you don't need to run depend or poetry, especially when you are installing dependencies in containerized environments, or you just want to try and install dependencies into your environment that are managed by these tools.
Very cool. Definitely have to take a look at that. Well, thank you very much for taking the time today to join me and share the work that you're doing on Project Thoth. Very interesting project, and it's great to see more investment in the ecosystem and the community and helping people find the optimal set of dependencies for their projects. So I appreciate all of the time and energy that you and your coworkers are putting into that, and I hope you enjoy the rest of your day.
Thank you. Thanks for having me, and have a great day.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.